Hey guys, Mr. is here to help you out on the second part of the chapter 3. So we're still going to be solving equations, but this time we're going to use a different method. And this one's going to be called substitution. So if you remember here, when we're trying to find a system of equations, we're trying to find the x and y values that work for both equations. And graphically, it's really nice because we're just figuring out where the lines cross. But we do have some problems here. Like say we have a graph here and we have two lines, but where they cross, like say we have a line that goes like this and a line that goes like that. Well, it's like, what if we have this point and it's not exactly like right at a nice location? Like, okay, we know it's probably 1, but like, is it 1, 1.5? Is this 1, 1.6? Like, what happens if that intersection point is not a nice whole integer? Or what if we have two lines that cross, but it's like way outside of our graph, like way up there? Do we want to go through and make the grid? So we can use another method here called substitution. And what it needs to do is basically 4 steps. First thing we're going to do is try to get one of the variables by itself. It doesn't matter if it's an x or a y, but we're going to look to see if we can have one variable by itself. Then what we're going to do is we're going to substitute that variable into the other equation. So that means we're going to take what that variable is equal to, and we're going to replace it into the equation. We'll then solve for that variable that's left over, and then take our answer and substitute it back into one of the equations to figure out what the other variable value is. Okay, so we'll walk through this here, 4 steps. Okay, first step, we're going to look to see if we have one of the variables by itself. And we do. We have x is equal to 4y. So the second step is we're going to take our other equation. Wherever we see an x, we're going to change it to a 4y. So this is going to be 4, not x, but 4 times 4y minus y equals 75. So just take a second, make sure you can see that here. Since x is equal to 4y, in this other equation, we changed the x to a 4y. All right, so now for step 3 here, we're going to figure out what y equals. We're going to solve for that. So if we did 4 times 4y, okay, that's 16y minus y equals 75. And 16y minus y gives us 15y's. Ooh, started writing. There we go, perfect. And if we divide by 15, 75 divided by 15 is 5. So now that we have this, step 4 is we're going to take one of these answers, this answer here, and we're going to plug it back in. We could plug it back into either equation. I kind of like going back to this one here because it looks a little bit easier to do. And we're just going to figure out what x is by plugging in 5 for y. So we substitute that answer in. We actually use substitution twice here. And x equals 4 times 5 is 20. So that means our point is, now remember with points, we put the x first, then the y. If we were to graph these two equations, it would cross at 25. X would be 20, y equals 5. So that would be one that would be really off of our grid here, but we can use algebra to actually solve this. All right. Now, if you want to try this one on your own, you think you got the hang of it, feel free to pause this video and watch it. If not, let's keep this going here. Okay, since y equals 2x, we're going to change this y to a 2x. So we get 3x plus 4 times, not y, but 2x equals 11. All right, we're going to work on solving for our x. We got 3x plus 4 times 2x. That would be 8x equals 11. Add them together, that'd be 11x equals 11. And then when we divide by 11 to get the x by itself, x would equal 1. Then the last step, now that we figured out what x equals, we're going to plug it back in. We could plug it into either equation. I like to go to the simpler one. Y would equal 2 times 1, because that's what x equals. Y equals 2. So this one wouldn't have been tough to graph, but we got it set up. Oh, so if we named it as the point, x goes first, y goes second. 1, 2. Okay. Let's practice this one here. All right, well, notice here we have y's by itself on both of those. So it technically doesn't matter. But I'm going to just say, since y equals 2x plus 3, I'm going to change that y to 2x plus 3. So we're going to say 2x plus 3 is equal to 4x minus 7. This one looks a little bit different, but just kind of see what you did. We since y is by itself here equals to 2x minus 3. We replace this y here with the 2x plus 3. All right, now to solve this one here, we got y's on both sides, so we're going to subtract the smaller, or we got x's on both sides, subtract the smaller x. So we get 3 equals 4x minus 2x is 2x, 7. Add the 7 over, and we'd get 10 equals 2x. Divide by 2. All right, x would equal 5. Then to figure out what y equals, we're going to plug it back in. It doesn't matter which one we plug it back into. I'm plugging into that one there. Y equal 2 times x is 5 plus 3. That'd be 10 plus 3 or 13. So the answer for this one here would be x is 5, y is 13. Okay, well, if you remember with graphing, sometimes we can have special cases where the answers never came out nice, or actually we didn't even have answers because there'd be no solution where the lines were parallel, never crossed each other, or they were lines right on top of each other. And that can still happen with substitution. We'll show you how those look like. All right, so here we got y by itself. Y is equal to a negative x plus 4. So I'm going to change this y here in this top equation to a negative x plus 4. So we get 2x plus 2 times negative x plus 4 equals 8. All right, if we distribute this here, we get a 2x plus, actually not really plus because we have a negative. So if we distribute that 2 times negative x is a negative 2x. 2 times 4 is 8. All right, now these x's are on the same side, so they can combine together, and 2x minus 2x goes away, and we get 8 equals 8. So the problem here is we have no x that we can solve for. The x has gone away. So whenever the variables cancel each other out, you're left with either no solution or all real numbers. And the difference between the two is if you look at this, does 8 equal 8? Yes. And so that means we're going to have infinite solutions, or the answer is going to be all real numbers, meaning we can pick any number, any solution that works for one of them is going to work for the other one. All right, let's check the other one. You might have a guess what this one's going to be, but let's see. Since y is equal to x minus 2, we're going to change this y to an x minus 2. So we get 2x minus 2 times x minus 2 equals 0. We distribute here. Get a 2x minus 2 times x is a minus 2x. Minus 2 times minus 2 is a plus 4. Now, just like here, our x's cancel each other out, and we get 4 equals 0. So once again, we have a special case scenario where we get either no solutions or all real numbers. Does 4 equal 0? No. So this one would be no solution. Okay. Now, what I'm going to have you guys do, if your CYU problems here for this section are these two here. So you can go on to Canvas and you can practice those. And then after this, just to build our skill here, you guys will also do IXL E6. All you need to do is to get a ribbon 70 or higher. If you have any questions, ask. But remember, now that we've learned this method, graphing also works. So if you guys want to graph these lines just to double check your answer, that's one thing you can do. All right, guys, have a good one. I'll see you later.